All right, guys, if you wouldn't mind putting those questions into chat, questions with commas, and I can just, go through anything you might have a question about. There's no right or wrong questions. It's just whatever. Everyone's different. Everyone learned different things at different rates, and we'll see what we can do. All right, I like this. 49, 24, no, 49, 40. Handle those. And I did mean like 3 questions each, not like just 1 question per person. But that'll get us started, I guess. 49 and 40. Page 24. Ooh, I like this. Question 40 is looking pretty popular. 24, 40, 49, 49. 40 and 49. Maybe I should just do 40 and 49. We'll call her a day. I'm just kidding. All right, question 40. Determine the area of the shaded region. So basically they're giving you a square, and that's denoted by the little hash marks here, letting you know that this is a square. So the sides are the same. If you want to know the area of the shaded region, would probably take the area of the whole thing, and then we will subtract the area of the white part there, and that'll give us the shaded bit. So what is the length of one of the sides of our square? Maybe take a step back. How do we find the area of a square? Well, it's length times width. And in this case of a square, the length and the width are going to be the same. So in this case, the length and width we could write as, this is x plus 2. And then we're going to add to that, sorry. We're going to add the lengths of both of these things. X plus 2 plus 2x minus 3. So what I've done is I've taken this length and added it to this length, because that's going to give me the whole length from top to bottom. All right, so I have a 2x and an x. I'm going to combine like terms together. So I'm going to combine my x's, and then I'm going to combine my constants. So 2x and x gives me 3x. Wasn't hoping for green. Let's try that again. 3x, and then 2 and negative 3 is minus 1. So that's the length of that side. So if I want to take the length of the whole square, including that white little block, I'm going to have the length. Area is going to be length times width. So 3x minus 1 times 3x minus 1, or 3x minus 1 squared. All right, 3 times 3 is 9, so I'm going to FOIL. First, outside, inside, last. Multiply that there. Outside, inside, last. So 3 times 3 is 9. X times x is x squared. 3x times negative 1 is negative 3x minus 3x plus 1. So there is my FOIL. I'll just combine my like terms. 9x squared minus 6x plus 1. All right, so that is the area of the whole shape. And I also need to take the area of just this little one here. And I know that the length of one of these sides is x plus 2. So to find the area of the red square, do it over here. I have x plus 2, which is length. times x plus 2, because length times width gives me the area of a square. So x times x is x squared plus 2x plus 4. All right, so combining my x's in the middle there, 2x and 2x gives me 4x. So that's given me the little square. This down here is the big square. If I wanted just the shaded area, I'm going to take the big square and I'm going to take away the little square. So what I'm going to do is I'm going to go run out of room here. This might not take too much room. Do it over here. I'm going to take the big square, 9x squared minus 6x plus 1. And then I'm going to subtract from that x squared plus 4x plus 4. So 9x squared minus 6x plus 1. Then I'm going to take away, now I need to subtract everything in the bracket. So minus x squared minus 4x and minus 4. So I've flipped all the signs because I had this minus sign here, so I need to distribute that minus 1 through the brackets. All right, combining like terms. I have 9x squared, I have minus x squared. I have 6 x's, I have minus 4x, and then I have plus 1 and minus 4. So I'm just going to combine all those together, see what I end up with. 9x squared minus x squared is going to be 8x squared. 6x minus 4x is minus 10x. And then plus 1 minus 4 is going to give me minus 3. So that would be letter D. It's a really good question for you guys to ask. It's a bit of a tricky one, but I don't know. It's kind of all things that you know how to do. I mean, you know how to expand, you know how to distribute. It's just a really tough question because you just need to remember how to do so many things at once, I guess. And yeah, it requires a lot of work. Obviously, what did I do? I had to add some polynomials, then I had to multiply them, and then I had to multiply some other ones, then I had to subtract. So like 4 steps for one multiple choice question. That was a good one. Thanks for asking that. Page 24, 40, and 29, 49. 49 was another question. The following diagram shows a right square base pyramid placed on top of a right square base pyramid. Which of the following calculations will determine the total volume of the combined object? I like it. Obviously, we have 2 shapes here. We have this square base pyramid, and then we have this rectangular prism. So we're going to have to find the area of both those things independently. And then once we've done that, we can add them together. I will need our formula sheet. And remember, you don't have to bring a formula sheet with you on Wednesday. I'm going to print one off. It'll be waiting here for you. But you should be familiar with things on the formula sheet. So you should be able to figure out where things are. So what do I want to do? I want to find a formula sheet because I don't have the formula memorized, so I need to figure out where my formula sheet is in all of these units. Learning guide, no. Unit 2 would have had some formula sheet stuff in it. Caliper lesson 3, about that, no. Lesson 6, Unit 2 Learning Guide, formula sheet. There we go. All right, so we have a square-based pyramid, and then we have a rectangular prism. So we have each of these things to deal with. I'll probably just write this down. So to find we're asking for volume. The total volume. So we're going to use the volume formula, which is 1/3 area of the base times height. And then the rectangular prism is going to be the area of the base times the height. I just jotted it down so I wouldn't have to flip back and forth. Okay. So this is our, I guess I did it in red, so it makes sense for me to do it in red down here. Pyramid volume is equal to 1/3 area of the base times height. All right, so the area of my base is going to be 8 by 8, and then it tells me my height here is 3. And I don't want to confuse my slant height with the height. Remember, those are two different things. So 1/3 area of the base times height. Let's go with that. So 1/3, the area of the base is going to be 8 times 8, and then I'm going to multiply that by a height of 3. All right, I'll leave that for now because I'm going to try to match it up with one of these. And you'll notice that the answer, although the answer could be written as just a single number, like 12,742, that could be the answer. The answers aren't written like that. It's written as, you know, each piece of like, so it kind of wants you to do your steps and then figure out what answer best represents the steps that you chose to do, trying to match it up. So let's go with the rectangular prism. Volume is going to be the area of the base times the height. And the area of the base of that guy is going to be 8 times 8 as well. So it's going to be 8 times 8, and the height just was 12. Now, if I'm trying to figure out the volume of the total shape, I'm going to have that triangular prism on the top, the rectangular prism on the bottom. I'm going to have to add those together. So I'm going to have to add the top and the bottom. And in the answers that are given to me, I don't know which order they've done them in. So I'm just going to have to, you know, hope for the best. I might just do the red one first here. So this is total for both the top and the bottom. 1/3 times 8 times 8 times 3. And I'm going to add to that the bottom, which was 8 times 8 times 12. Okay, let's see if I can find an answer that kind of looks like that. 8 times 8 times 3 divided by 3 and 8 times 8 times 12. I'm thinking it's looking just like A. Is there a better answer that I'm missing? Because 8 times 8 times 3 divided by 3. So this is the pyramid. And then I also have the 8 times 8 times 12 for my prism. And I'm adding them together. It's definitely going to be A. I'm liking it. And obviously that is in a different order. They switched the order as opposed to what we had written down here. I don't think anything else looks better than that. So we'll go with A. All right, I asked each of you to put 3 questions in. 2 of you put 2 questions in. Perhaps there's another question out there. Sometimes with these provincial exam type questions, you know how to do the stuff, you just don't know really where to, like, you don't know what the question's trying to get at. So sometimes it's a bit difficult to, determine what the question's trying to get you to do. Question 35, page 22. Which of the following simplifies to a over b? Exponent laws. I don't know why. I think it's just like students maybe don't get enough practice with the exponent laws in this unit. I think this is unit 3. Yeah, I don't know what it is. I don't know, but you just got to remember your exponent laws, and obviously they're not on your formula sheet. It'd be really great if they were, but they're not, so you can't just rely on that. You just basically have to practice them enough that it just becomes kind of second nature and you get used to dealing with them. All right, does anybody remember what a negative exponent means? What does that look like? What happens if we have a negative exponent? What do we do to our base? And then, does anybody remember what a fractional exponent does? So if we're looking at something like a half, what's that going to mean for us? So we have kind of two major exponent laws we're dealing with here. If we have something that has a negative exponent, let's use x to the negative 1, that's going to give us 1 over x. So if we have a negative exponent, we take the reciprocal to make the exponent positive. Or I could write something like x to the power of negative 2 would be 1 over x squared. So if I flip it, the exponent becomes positive. The other thing we have here is fractional exponents. So I had x to the power of 1/2 is equal to the square root of x, or x to the power of 1/5 is equal to the 5th root of x. That was the flowers the power root is the root example we looked at. So if we're looking at 35, I see that letter A here, if I have a negative exponent, I'm going to take the reciprocal, so that's going to give me negative a over b. That doesn't look the same, so that is not the answer. This one here, I have a negative exponent, so I'm going to flip it first. So I'm going to get b squared over a squared. Now that makes my exponent positive. See how they try to throw in kind of little curveballs at you by throwing a negative sign out front here? Some people think, oh, negative exponent, negative down here, it's going to be positive. That's a common mistake students make. The other one is the fractional exponent. Sometimes you think, oh, I take the reciprocal, and some students will try to flip the exponent instead of flipping the actual base. Now I'm going to have the square root of b squared over a squared, and that's going to be b over a, which is not the same there, so it's not that. Same deal here, I'm going to have the square root of a squared over b, which is going to be a over the square root of b, which is close. And this one, I'm going to flip it. So I get a squared. Put the toolbar on the side, they say. That'll help. Completely lost one node in the process. All right. So I'm going to have, I can flip it. I'm flipping it. Negative exponent, I got to flip it. Oh boy. A squared over b squared, all to the power of 1/2 positive, and then the square root of a squared over b squared. I think this computer's going back. Okay. A squared over b squared, and then positive 1/2 then the square root of a squared over b squared is going to be a over b. And that's the same. So the correct answer is D. We did it. Okay, so exponent laws. I would say that exponent laws are the biggest section that the students do the worst on. I'm not saying you guys are bad at exponent laws. I'm just saying that the questions you see on exponent laws, if you're in a factoring unit, you can kind of do the easy factoring ones, and then you get to some of the trickier trinomial ones, and you don't know how to do them, you'll be okay, because you could do some of it. But with exponent laws, there's no kind of like easing your way into it. Generally speaking, you'll get a question like this. It's asking two laws, essentially. It's asking you the negative exponent law and then the fractional exponent law. So, I mean, if you're not up on your exponent laws, then you're probably really going to struggle with something like that. So it might be worthwhile to look back at your exponent law stuff. I don't know. It's up to you guys. Whatever you feel like you're going to get the most benefit out of. Obviously, you want to focus on studying things that you need to review or didn't learn the first time, and then kind of go biggest bang for your buck. All right, question 35 is done. Eric is almost going through the exam to find a question to give me. I think Leeds gave me 2 questions. Christina gave me 2. So I'm still waiting on 3 questions from any one person. 3 questions, that's all I asked. If you want, you can just put random numbers in. That'll work. Or I can just leave you with the exam, and you can, we can go through it next day. 33. I feel like that was random, Eric, but I like it anyways. Let's go for it. Ooh, prime factorization. All right, thank you, Christina. You've done your quota of 3 questions now. Question 33. Using the different prime numbers a, b, and c, the prime factorization of x, y is determine the least common multiple of the numbers x and y. So this gets back to the idea of least common multiple is found by taking the largest exponent of each of your prime factorizations and multiplying them together. I'm trying to think of the least common multiple. Is that in unit 4? Just trying to think. I don't remember what unit that was. Properties of functions and function notation, relations. I thought it was in unit 4. Polynomials. Maybe it was in unit 3? Fractional exponents, exponent laws. Oh well. All right, so it's just kind of a basic definition type deal. We need to take once we've taken numbers, like it might be confusing when you think of using different prime numbers like a, b, and c. Don't think of it like that. Think of it as a number like 24, and let's think of a number like 17. Maybe not the best example, but let's just go with it. So the prime factorization of 24. I'm going to go 6 times 4. 6 is 2 and 3, and 4 is 2 and 2. So what is the prime factorization of 24? Well, 2 times 2 times 2 times 3, or 2 cubed times 3, that's going to be 24. So that's the prime factorization of 24. I can do the same thing with 17. I can go 17 is 17 times 1. Well, that is the prime factorization. 17 is 17 times 1 because 17 is a prime number, so I don't have to do anything with 17. So when you see something like a times b squared times c, this is kind of like a cubed times b. That's kind of what they're doing here. So instead of thinking of it in terms of variables, you want to think of it in terms of numbers that might help out. 2 cubed times 3. All right, so the least common multiple is going to be the largest exponent of each of my prime numbers. So I'm going to have I'm going to go for the biggest exponent of each of these. So the least common multiple is going to be a squared is the largest exponent for a, b cubed is the largest exponent for b, and c squared is the largest exponent for c. So the least common multiple or the lowest common multiple of those three numbers, those two numbers, x and y, is going to be a squared, b cubed, c squared, which is a squared, b cubed, c squared. It's going to be letter C. There you go. So that was just kind of remembering that definition. How do I find the least common multiple? And there was two ways I showed you to find the LCM. And this is how they make sure you're not just multiplying numbers. The other way you can find the LCM is just multiply the numbers. So if I had 24 and 17, I could go, okay, 24 times 1 is 24, 24 times 2 is 48, 24 times 3 is 72, and just keep going like that, and then I could have 17. Okay, 17 times 1 is 17, 17 times 2 is 34, 17 times 3 is 51, and just keep going until you end up with the same number. So I would have to end up with the same number up here and then down here, and that would be the least common multiple of those two. So repeated multiplication will find you the LCM, as well as taking the largest exponent of each of your prime factorizations. So you can see in this question, 33, instead of giving you numbers to find the least common multiple, and just saying like, what's the least common multiple of 24 and 17, they're forcing you to remember the exponent method of finding the LCM, which is, it's clever. I'll give them that. Very clever. All right, that was 33 for Eric. Jesse is unsure of anything at all. Christina wants 50. The page numbers were helpful, but I can find it. It was close. 50 is probably in this last unit. No. 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 There it is. Okay, both objects have a radius of 10 centimeters. Describe the relationship between the surface area of object A and object B. That's a good question. So we have surface area of a sphere. I'm going to go back to verify the surface area of the sphere formula. Surface area of a sphere is going to be 4 pi r squared or pi d squared. I like 4 pi r squared better. I'm going to write that down. 4 pi r squared. It says the radius is 10 from here to the edge. That's 10 centimeters. All right. What's the relationship between object A and object B? If I'm speaking of the surface area, if I'm talking about the volume, I've taken a quarter of it out. What about the surface area? What is object B missing in terms of surface area? Is it missing half of the surface area? Or an eighth of the surface area? Or a quarter of the surface area? It's definitely missing a quarter of the surface area. So I can take the surface area of object A, and you'll notice that all of these answers are in terms of pi. So this is surface area object A is going to be 4 pi times 10 squared. 10 times 10 is 100. 100 times 4 is 400 times pi. So that's the surface area of object A. The surface area of object B is going to be, I'm still going to need 4 pi times r squared, but what fraction of the surface area do I have left in this whole bottom part and this other piece on the side? I have 3/4 of the surface area left because I've lost 1/4. So instead of doing subtraction, saying, okay, what's the surface area? Okay, now take 1/4 away from that. I can just take the 3/4 of the surface area because that's what I'm going to end up with here. So the 4 and the 4 cancel. I get 3 times 100 is going to be 300 times pi. And then the question solution, say something like object A has 100 pi centimeters more, object B has 100 pi centimeters squared more, 50 pi. So I'm comparing 400 to 300. Object A is 400, B is 300, so 400 pi minus 300 pi is going to give me 100 pi. So object A has 100 pi more than B. That's a good question. I like that question. Notice that when you get into grade 10, they're not just going to ask simple questions like, what's the surface area of this object? They're going to make you find the surface area of 2 objects, subtract them, add them, do something like that, composite objects, things like that. So it's just a different way of getting you guys to put the knowledge you have learned into action. And you just gotta kind of have confidence in what you're doing. We can't do every sort of iteration of every question possible in class. We do as many as we can. We try to do the ones that are going to be most common. But questions like this, you should be able to kind of figure out, hopefully. And you just got to kind of work through it and just be confident in what you're doing, confident in your math. So that's 50. We have 26, 45. And I think that's kind of it for now. 26, 26, 26, 26. Lines A and B are perpendicular and intersect on the y-axis. The equation, this is an evil question. This is an evil one. They intersect on the y-axis. The equation of line A is -3/2x plus 4. What is the equation of line B in slope-intercept form? All right, so this is kind of what we've just been talking about in terms of lines. There is 2 key pieces of information in the question. Line A, we get the full equation, which is kind of nice. And the second piece of information is this. The lines, there's actually 3 pieces in here. The lines intersect on the y-axis. All right. Might not be as difficult as I first expected. We also see that the lines are perpendicular. So 3 things we need to know here, or 3 things we need to kind of remember about lines. The equation of the line we're given here, line A, is in slope-intercept form, so I know the slope and the y-intercept of it. It turns out that I know the y-intercept of line B. Because line A and line B intersect on the y-axis. Where does line A cross the y-axis? At what point? Well, this is going to be 0, 4. That is the y-intercept. So line B has a y-intercept of 0, 4. It has to. So that means if I put it into y is mx plus b form, I can put a 4 here. Y is mx plus 4. Because I know that these 2 lines intersect on the y-axis. That means that their y-intercept is the same. If I draw a graph, one's there, they're perpendicular, they both intersect there. They both go through that point. That's a really useful piece of information. The second thing I know is that they're perpendicular, and lines that are perpendicular have negative reciprocal slopes. So that's kind of the fact that you need to remember. This is the slope of line A. If it's perpendicular, the slope of line B is going to be the negative reciprocal. So I'm going to flip it. and add a negative sign. It already had a negative sign, so 2 negatives give me a positive. 2 over 3x plus 4. That was a good question. Wasn't as much work as I initially thought it was going to be when I first looked at it. Okay, 26, 45. 45, 45, 45. Ooh, that's a good guess. Yeah, this is kind of a weird question. Okay, Eric, we'll get to that. 45 is asking about the referent. So in class at the very beginning, we talked about like estimating different lengths. So we could say something like a foot in the imperial system is about the length of quite literally my foot. Or a meter is about the length of my arm from the tip to the middle of my chest. That's about a meter, so that'd be a referent. This one's asking about 3 inches. So I know 3 inches is roughly about 2.5 centimeters to an inch if I just estimate it really roughly. That's about 6 centimeters. So if you can't really think about what 3 inches looks like, think about 6 centimeters. So you have a centimeter, that's 5 and then 6. So which one of these best represents 6 centimeters? If I took like my whole hand from one end to the other, that's pretty big for 6 centimeters. Like that's really long. If I took that, that's pretty close, maybe like the top to the bottom. If I took 2 fingers, if you think like each finger is about a centimeter, that might be a little bit too short. And then if you take your whole hand, that might be too long as well. So I'm thinking the best referent is going to be A. About 3 inches would be 6 centimeters. That's about the top of your hand to the bottom. And it just kind of depends on how big your hand is, but you just need to pick the most correct answer. The hand's too long from one side to the other. If you have this thumbs up thing, too tall from the top to the bottom. A weird one. But there will be a referent question likely on your test. There always is. So that's what a referent is. That was 45, and then 42. Which expression below has a factor of x plus 3? So factoring question. So instead of saying, here's a trinomial, factor it, they're saying, here's 4 trinomials, which one of them has a factor of what we're starting with? So it's an evil way of making you do 3 questions, or 4 questions, I should say, instead of 1. They could have said, okay, take x squared plus 9x plus 9 and find the factors of it. So you'd go, okay, magic number's 9. What numbers multiply to 9? Add to 9. Go through it like that. So I guess the trick here is some of these aren't factorable. Like A, you can't factor that. There's nothing common you could take out of x squared and 9. And because it's a plus sign in the middle, it's not a difference of squares. So we can't factor an addition of squares. So we can't factor it. That's not going to be the answer. We can't do anything to that. X squared plus 3x plus 9. Now, I know Mr. T went through factoring with you. There's many different ways to factor things. I've seen students from Germany factor different than students from Canada factor different than students from Japan. Every country seems to have their own way to factor things. You can draw shapes, you can do whatever you want, whatever kind of works best for you. What I always do is I look at the last number and I say I need numbers that multiply to 9 and add to my middle number, which is 3. So what are numbers that multiply to 9? Well, I have 3 times 3, and I have negative 3 times negative 3. That's it. Oh, I have 9 and 1, I should say. 9 and 1, and negative 9, and negative 1. So which one of those add to 3? None of them. 3 plus 3 is going to give me 6. This is going to give me negative 6. This is going to give me 10. This is going to give me negative 10. None of those add to my middle number. So the second one we can't factor either. This one is looking promising because 3 and 3 gives me 6. So if I wanted to factor this, I could have x plus 3 and x plus 3. And then this one here at the end, we can't factor as well. So it would have to be C. That's the only one out of the 4 choices that allows you to factor it. So factoring question just kind of backwards, I guess. So that was 42. We've got 10 minutes left, or 6 minutes. If there was maybe one more question, we could do it. Or what we can do is I will leave you guys with the rest of that exam. And next day in class, you guys can come back with a bunch more questions and we can go through them. Or you can ask anything you had questions about. Like next day, don't think you have to come with a question related to this exam. If you have a question that is completely not on the exam, that's fine. If you're just saying like, hey, Mr. Borden, I really don't remember how to factor a trinomial that has a number in front of the first term, I'd be happy to go through that. So soccer team organized year-end awards. The cost in C dollars to book a restaurant is determined by 15p plus 300. P represents the number of people. The total cost for the evening was $630. How many people attended the event? So this is kind of a function notation question. It says that 15 times the p. So what does this equation really mean? Let's just rewrite it. C as a function of p is 15p plus 300. So this 300 is what we call the initial cost. So remember, this equation's representing something. The cost of having a party. The 300 is the initial cost. So that would be kind of like renting a hall, something like that. You have to pay $300 up front, and that cost is fixed. It doesn't matter how many people attend, the cost to rent the hall is going to be the same. So that would be that 300. And then you have this 15p, and this is the cost per person. This would be something like food. If each person sits down, they have a plate of food, that food costs you $15 to give to them. If 2 people eat food, well, you have $30. If 200 eat, well, you have another $300. It just depends on how many people are eating. So the question says the total cost was $630, which is this. Is going to be 15 times the number of people plus the initial 300. So it's asking how many people attended the event. The total cost was $630, and then you had 300 of that $630 was the initial cost to rent the hall or whatever, wherever they're dealing with this. So I can use algebra, I can use my brain. If I want to think about it in terms of algebra, I'll subtract 300 from both sides. I'm trying to isolate this guy. So this gives me 330 is equal to 15p. And then I'm going to divide both sides by 15 because each plate costs $15. And 300 is 20. Is that 22? In my head, it's 22. In my calculator, it's 22. Sorry, I shouldn't have written 15p here. I should have just written 15. That gives me 22 is equal to p. So that means 22 people attended the event. Now, on your exam, you're going to have a bunch of boxes. It's going to look like this. There's going to be 2 circles, one for plus, one for minus. You're going to have 3 boxes, then a decimal, then another 2 boxes, and you're going to fill it in. So you can fill in the positive bubble if you want. If you leave it blank, it's assumed to be positive, and then you're going to put a 2 and a 2 in there, and that's it. So that is what those types of questions will look like on the test. Hopefully that helps you, Jenna. I have to go teach my 8s now. So next day we have an hour and 15. I can stay longer if you want, as long as you guys need. I would encourage you to, if nothing else, go through all of the questions on this exam, and I'll put up the solutions this afternoon. Go through, check your answers. If you got something wrong and you're not sure why, come back with that question next day. As well, if you come to class next day saying, hey, Mr. Borden, I really don't remember how to take the volume of a sphere or a cylinder or something like that. Can you show me a few questions like that? I'll find questions or just make one up and we'll find it. So we'll just go through anything you have questions about next day. There you go. So the kind of mark cutoff is today. Anything submitted today will get marked. Anything not submitted today will not be marked. Your grade is updated in Moodle, so you can just go check your grade. That's what you'll finish with if you don't do any more work. And whatever you get submitted today, or if you submit something over the weekend I haven't marked yet, I'll get to marking that as well. So I will leave you guys there. Thanks very much. Come tomorrow with questions, and if you have anything that comes up between today and tomorrow, let me know. And we will see you guys later. Bye-bye.